Hello everyone, and welcome to part 2 of the Raylib Asteroids miniseries. I just want to quickly say, if you haven't seen part 1, I would recommend you go and watch that first. There's a card in the top right corner of the screen and a link in the description. Between this and the last video, I've done a bit of cleanup of the project structure. First things first, I moved all of the debug stuff into a debug header. In this debug header, I have a show debug menu, a show debug visualizations, and set last cone to set some debug values, and we'll probably need to make other functions like this as the project grows. Show debug menu handles the toggling of the menu with the grav or tilde key, and then everything else drawing the menu itself is all in here. We also have the debug visualizations, so the angle cones and the asteroid count, and of course the set last cone logic as well. This allowed me to move all of the debug specific values into their own translation unit and make them all static. So the game logic actually doesn't touch any of this stuff. Instead, game logic can choose to provide information to the debug family, and then they can do whatever visualizations they need. I also added a constants header where I can just put any of the preprocessor directives that apply to the entire game loop. So things like the size of the screen and common colors, sure, that's helpful. But then also things like this, how many asteroids are going to be in that array, since many different files will need to iterate over something like that array, and some more asteroid specific. These are specific to spawning asteroids. I also created this game asteroids header, which has the add asteroid and get next asteroid position logic from before. I also added an update and draw asteroids, so we can see this main function is still really clean, but also the update draw frame is now extremely clean again. You can see I update the asteroids, and it's going to return an integer, which is going to be the number of active asteroids that I can use for the debug visualizations. In the draw loop, I can draw the asteroids, show the visualizations, and then show the debug menu. In the case where these visualizations aren't being shown, they won't be shown, so we don't have to worry about that. Draw asteroids is really simple because it's really just iterating over all the asteroids and calling asteroid draw. Update asteroids is a little bit more complicated because there's technically two control structures. There's a for loop to update all of the asteroids, which this is really just going to apply the velocity and the rotation and check the lifetime. And it also checks if it's time to spawn a new asteroid. But again, the reason to move all of this logic into its own file is that some of these things can now become static and be limited to those translation units. This way, in main.c, I can basically say, draw the asteroids, update the asteroids, and keep this file extremely short. Look, we're at 44 lines. Now, I'm not going to worry too much about maintaining this pattern. I'm going to add things wherever I want to add them, and then between videos, I could always turn around and say, okay, I'm going to refactor this a little bit, and I'll always include that refactor as a time lapse at the end of the video. Now, let's get on to the real topic, which is adding the ship. I'm going to add two new files, player H and player C. The player is going to have a position, a rotation, and a velocity. As I said, I'm not worried about organizing things too neatly, so I'm just going to include the player file here directly. And then I can create a player. Now, while we're working on this, I'm going to go ahead and pause the drawing of the asteroids. I just think it's going to be really distracting. I've created a static player, and I'm going to give it an initial value. I'll start them off in the center of the screen with velocity of 0 and a rotation of 0. I'll add these to my code file. Drawing the player probably doesn't need to have a pointer. When we draw the player, I'm just going to draw a polygon at the player's position. I'll just make it a triangle, just like with the meteors. In player update, since I'm using C, I can actually cast booleans to integers. So I can take the difference between these two integers. This will be 1 when we're pressing right and 0 when we're not. Same thing for this one. 1 when we're pressing left and 0 when we're not. I get a 1 if we're pressing right, a -1 if we're pressing left, and a 0 if we're pressing both or neither. I can use that multiplied by the player rotation speed and times get frame time and modify the rotation each frame. And I'll just make sure to draw a polygon, which will just be a triangle, at the player position based on the player rotation. I'll just hard code a 64 for now, and I'll make sure that it's white. In main, on my update draw frame, I'll remember to do the player update. And I'll be sure to draw the player as well. Okay, so I can see that when I start, I'm pressing left, and left is turning me right, and right is turning me left. So that's an easy thing to change. I can also see that I'm starting facing down, but I would actually like it if I started facing up. I'll just start my rotation at 180, and that should start me facing up. I'm going to make the triangle a little bit smaller because being that big is kind of embarrassing. I'm also going to add something to the debug to include some player visualization stuff. Next, what we want to do is make it so that when I press forward, the player actually moves in the direction they're facing. I'm going to do the same thing I did for the X input for the Y input. Supposing I've written working code, this is what will happen. If we're holding up, then I will calculate the facing direction by rotating a vector pointing straight down by the player rotation, since that's the default state of the player. The player velocity will then be incremented. I'll use vector2add to set the velocity equal to itself, plus I will scale the facing direction by a player acceleration value that I've added times frame time. So since this value is 200, that means if I was to hold up for a full second, our velocity will increase by 200. So I scale the facing direction by this value, which this will be normalized since this is a normal vector. When I rotate it, it's going to keep the same length of 1. I'm scaling that up to this value, so this should be the magnitude of the new vector, and adding that to the velocity. Now I compute the magnitude of our velocity after that add step, and if that magnitude is larger than what the player speed should be allowed to be, then I will set the player velocity equal to a magnitude of player speed divided by magnitude. So the current magnitude is magnitude. So if I divide the length by magnitude, I'll get a normalized vector, and then I can multiply it by the player speed. So assuming this works, this should make it so that I can steer the character, and as I press forward, I will accelerate in the direction I'm facing, and I should be able to cap out my speed at a particular value, which in this case is 250. So it'll take a little bit more than a full second to reach maximum speed. And then I should be able to change that direction, and I should be able to maintain that speed. Now at this point, there is no deceleration, so I should probably add something like that. So after I apply the velocity, I'm going to want to modify the velocity one more time. So at this point, I've got the logic working how I expect, and I was really just tweaking these values. Just as a quick note, if you're making changes only to header files, then simply building the project isn't enough. If you're using the same VS workflow that I am, which is described in one of my previous videos, then simply pressing F5 is not actually going to build these changes into the project. Since there was no change made to the player.c file, the changes made to this file, which is only imported to player.h and main, are not going to be felt in either of those files, and so we won't actually see any difference. So we might keep changing this value and think, why is this not working? Well, it's not going to work. You have two options. Either you can modify your make file to actually have the clean option work, you can see for Windows here, I have it set the way it was originally set, where it's going to use the delete command, which I don't think I don't know. I think I would usually just use RM with the way my terminal is set up, but you basically need to modify this Windows section to operate properly. And the thing is, we actually have a list of where all the objects are in their proper context. So if we just change this to delete everything that's in here, and then we're also going to delete the actual project. So that's project name, and then we want to include the extension. So if I modify my make clean to work this way, then in my terminal, I can say make clean. It's going to delete all of the .o files, and it's going to delete main.exe. Now you see it says the system cannot find the file specified. If I switch this to RM, then it seems to work. So I don't know. I don't know what the deal is with the del command, but if I use RM, it works for me. So, you can experiment with that and figure that out. Now, if you can't seem to get this to work and you don't want to bang your head against the wall, and honestly, when it comes to makefile, I would say don't worry so much about it. You can just go to your object folder or wherever the .o file is running up, and you can just delete them manually, which is exactly what the command normally does. Delete the O files, delete the exe, and now when you press F5, it's going to do a full build, which means it might take a little bit longer than your previous builds because it has to recompile every single file before building the executable. This guarantees you're doing a fully clean build, which means that it's going to reevaluate every single file. So it's going to take all of your changes into account. And this applies to any time you're editing just a header file. So if you ever find that your header file changes are not affecting the project, this is why, and these are the things you can try. At this point, I think I'm pretty happy with the player ship movement. It's a little bit floaty, but I can always modify the deceleration to impact that. So I think I like the turning speed. I like the way that the ship feels. That's all good. The thing is, it's kind of hard to keep track of how my ship looks because it's a triangle and any one of those points could really be forward. So the last thing I want to do is I want to bring my ship image in here. I can see in resources here I have my ship.png that I made. It's 32 by 32. I'll just quickly load this in here. And when I draw the player, I'm going to pass in the texture for now. I'll probably refactor this at some point. So instead of drawing the polygon, we're going to actually draw a texture pro. The texture is the parameter. The source, I can actually hard code this source. Then we have the destination. This is the part that's actually going to change. So I'm going to use the player's position X and player's position Y. And for now, I'll just use 48, 48. Next, we need an origin. I want this origin to be half the size of the destination rectangle so that the player seems to be drawn from the middle. Then we need the rotation, which we have inside the player. And for the tint, I'll just use white. So now if I build, we can see that it's totally working, except that it's not. So we have to remember that when I was drawing the polygon, I based all of the rotation stuff off of what the polygon wanted. And I assumed that the point would be like the top of the triangle. But as it turns out, that is not at all how it works. So I have a few different options. I can change everywhere how we're using player rotation, or what I'm going to do for now, I'm just going to subtract 180. Now it's pretty clear to me that at some point I'm going to want to go back and refactor the player rotation to make sure that the rotation is a little bit more honest. So I'm assuming that straight up is the default rotation, but really it was straight down, or maybe it was. I think what happened was the default rotation is straight up. I assumed it was straight down because the poly had a weird draw style. Anyway, the point is I'm going to have to refactor it a little bit, but that's something I can save for the next part. At this point, I like the player movement. I think it feels pretty good. I mean, it's a little bit slippery, but I think that's going to be part of the fun, so you can kind of get a speed like this and then turn sideways and shoot. Just for fun, I'm going to turn the asteroids back on just so we can see it all come together. Give me something to dodge. Get the damn cursor out of the way. Nobody likes that. I'm sure the comments. Oh, okay, yeah. So this is hard, man. I don't know what we could do to spice it up. I mean, I don't know if it really needs spicing, but I mean at this point, obviously some tuning of the values is going to be necessary. But the important thing is that everything is working together. So let's look at what I did for the player update, because I kind of just said I'll work on this, and then suddenly it was working. So we have this. This is from before. If we press up, we find out the facing direction, yada, yada, yada. This is just us updating the velocity. And then later we know that the velocity updates the position. But on the frames where we're not actually inputting anything, we're going to apply deceleration. I didn't want to apply this when we're actually applying velocity because it just didn't feel as good. So on frames where we're not modifying the velocity, if we have a velocity, we have this mag calculation from earlier. If our magnitude is non-zero, I calculate the square magnitude. Actually, yeah, let's fix this. So there's vector 2 length, there's also vector 2 length square. So we'll make mag square this, and then we'll make mag the square root of the mag square. Probably, well, I don't know. Let's see if I can get away with not including anything. We have the mag square and then the mag itself. So anyway, I find out the sign of x and y. I could just use an absolute value for this part down here, but I want the sign for later. So I find the sign for each of these values. If it's less than 0, it's -1, and then otherwise I just use 1. Then that means if I have the signs, I can calculate the absolute value by just multiplying them by their sign. Next, I calculate the weight of the x and y. So this is me finding out how much of the velocity is caused by a horizontal and how much of it is caused by a vertical. The way I find this out is I just square the absolute value and then divide it by the square magnitude of the velocity. This got the feeling that I wanted for the deceleration. It's not really the most scientific method. There's maybe even better ways and slightly more efficient ways, but at this point, I'm happy with how it feels. Once I have the x and y weight, I can find out how much x and y should be decelerated. I take the weight, multiply it by the player deceleration, reintroduce the sign of the velocity, and scale it all by frame time. I do this for x and y, and then lastly, I set the value of the player's velocity component-wise. I use a ternary to decide between a difference and just directly setting the value to 0. If the absolute value of the velocity is greater than the deceleration, then I can just do this difference, and this will work just fine. But if the velocity happened to be less than the deceleration, and I did this difference value anyways, then every frame the player would appear to jitter in place as we're constantly nudging the velocity all over the place. So this is kind of my way of reducing the value instead of just a difference, because sometimes this is going to be negative and sometimes it'll be positive, but the point is I'm reducing the magnitude of this value. And then once the magnitude of the value is actually less than what I'm decreasing it by, I just explicitly set it to 0. The reason I do this all component-wise is because I want the x and y to be decelerated at different rates based on how they contributed to the velocity. If I applied a general deceleration to both components, then there would always be a moment when I'm moving diagonally where I'm no longer moving vertically, but I am still moving horizontally, and the character would appear to slide in a very strange way. This way, the player should always come to a stop in both directions at just about the same time. At this point, I'm pretty happy with the way the ship movement is feeling. I'll probably still end up tweaking some of the values a little bit, but I think the code is in a place where everything else that I want to change about its movement, I can do just by updating the data. The thing is, I realized none of these values need to be in the player.h, and they could actually live inside of the player.c. This will mitigate the make clean issue that I was showing a workaround for earlier, but it will also help reduce the number of identifiers that pop up whenever I ask IntelliSense to help me remember the name of something. The only thing that's missing is we need the character to wrap. When they exit the screen, it's going to be very difficult to find our way back to the screen because we don't know where they are, and at this point, I thought I would have been back on screen by now, so who knows where my player is. So let's go ahead and add in that wrapping. Player update is getting a little chonky, so I'm going to refactor this into a couple of static methods. See, some of programming is writing clean code in the first place, and the rest of it is knowing how to hide it. Once we've updated the position, we can update the wrapping. So the idea here is that if the player goes off the right side of the screen, then we'll teleport them to the left side of the screen, and if they go off the left side of the screen, we'll teleport them to the right side of the screen. I'll do the exact same thing for the top and bottom. Okay, let's see if that works. Okay, this seems to be working just fine. The only thing that I don't love about it is that you can see if I play near the borders, it gets a little bit hard to figure out where I am. So what I want to do is make it so that if the player, when I wrap the player, I give them a nudge. So I check their velocity and I give it a minimum value in the direction that they're being nudged. I'll go with a nudge velocity of 75 pixels per second as a starting point. I might have to dial this down a little bit. So if the player's horizontal velocity is less than this nudge velocity, then I'm going to set it equal to that. And in the case where we're going off of the left side of the screen, I want to do the same thing, except I want to see if it's greater than this nudge velocity, and I want to see if it's greater than the negative nudge velocity, because I'm going left, so I want to give it a negative value. Okay, so I think there's really two problems at hand here. I think I want this to activate sooner, And I think I did want it to be higher. So let's try this. Okay, that looks pretty good. The only thing that's left is that these feel a little bit hand wavy. Like it's kind of hard to read this. It's not super clear what's happening. So I'm going to replace these with something a little bit better. So now I'm defining a field min and max for X and Y, and then I'm using those explicitly in these if statements. I think it just reads a little bit clearer. This has the added benefit of later, if we wanted to add some UI to the screen, we're not bound to use these screen width and screen height. It'll be easier to make changes here, and maybe we end up replacing screen width, screen height. We create a new pair, which is like field width and field height, and I can easily replace these in this one spot and not have to comb through this file. So at this point, the player controller is pretty good. I said it was a basic player controller, but I mean, the truth is it feels like I have all of the configurable pieces that I'm going to need to make this have exactly the feel that I want. At this point, I'm pretty happy with how all of this is coming together. This is going to mark the end of part 2. Be sure to stay tuned for that refactor time-lapse if you're curious. In the next part, we're actually going to add the projectiles to the ship so that we can split asteroids. And in the part after that, we're going to tie the whole thing together with a score and a game loop. Thanks for watching, and I hope I can see you next time.